Hi, everyone. So, as I was introduced, I'm Fabiana Clemente. You are more than invited to connect with me on LinkedIn. So, my main focus areas or interests are for sure data science, time series, and generative models. And those are the ones I'll be talking about today. And yes, I'm the person that decided to bring structured data for a conference where LLMs have been the focus point for sure, but I promise that it will be interesting and we will still have some LLMs in the middle. So, we are all talking about foundational models from DALL-E to ChatGPT, so they are just taking all the AI space by storm, for sure. But the thing is, all these transformations are happening very fast, and we might be thinking that, well, foundational models have sorted out. So they have solved a lot of the challenges that we have nowadays in different areas and different scopes. But truth to be told is that regardless of the potential and power that these models have, well, they don't solve everything, and we still have the same old problem, garbage in, garbage out. If your data is not good, for sure any of the foundational models that you are using won't be performing. And that's something I want you to have your thoughts on, because I'll get back to that later on. So, what is my motto, or something that I think everyone that is in the data science space should take on an everyday basis? Treat your data as your product, not your model. So, think your data as the product means that you should be putting the business needs at the heart of your data flows and data preparation. And that's the foundation for the success of the AI adoption in any vertical or for any use case, either you're working with structured or unstructured data. So, prioritize your data quality. And yes, I know it sounds like a cliche talking about data quality and how data quality is the most important thing in your developments, but well, did you know, and this is a fresh report, so I think it came out this week from Anaconda, did you know that data preparation, data cleaning, and data visualization are the most consuming tasks in AI development? Yes, this is surprising perhaps for the most of you, because you know these are foundational tasks on the development of your models, all of them. You always have some sort of data prep. You always have to clean your data, and for sure, you always have to visualize the data that you are using. So how come are these still the tasks that not only take the majority of your time, but are also the tasks where there is less tooling available, or the tooling that you have available won't solve the most challenging aspects of these 3 steps? Well, and part of this talk today is really about data quality and data preparation, and how you can ease that step with using generative AI. So, the dimensions of data quality are huge. So depending on your use case, your business, you might have different dimensions that you should look or take into account. It is fascinating how many dimensions it has. So there is a paper called Dimensions of Data Quality that states at least 70 dimensions. So you have clarity, availability, accuracy, comparability, completeness, uniqueness, validity, and the list goes on and on. It does depend on whether you are applying on real time, if you are doing develops on a batch processing, or it depends of whether you are in a very regulated space, for example, compared to a space where there is more open and available data. So all of that counts. And today, I'll be exploring very specifically completeness. So everyone here have probably dealt at some point with missing data. And probably your missing data had different characteristics. So sometimes it's missing at random, sometimes not at random. But what does it mean to be missing? Do you have the context what led to that missingness? All of that impacts the way you decide or how you approach the problem of completeness. And well, incomplete data can be very damaging for any industry that you are working at. For example, if we take into financial areas, we can have, for example, inaccurate risk management, where the presence of missing data can lead to the underestimation or overestimation of risks, for example. It can also hinder quality control. For example, if we are talking about production industry, this can lead to poor identification of defects, for example, or even deviation in the production processes, which will lead for sure to losses in terms of business. And last but not the least, and especially in healthcare, can lead to medical misdiagnosis. And this is where you can see that the fact that we have missing data can really have high impacts on the way you develop your models, and particularly when your models are applied into production, how they can impact the applications or where they are being used. So, for example, in healthcare, definitely we can have patients misdiagnosed and misidentified when, for example, working with ECGs. And well, for that reason, there are particular workflows for working with missing data. And when it comes to time series, this is even more important, right? So you, of course, start with the data collection. You have to understand why you have missing data while you are collecting data, right? So are your data flows failing? Is it really something that is related with the nature of the elements or processes that are collecting your data that are leading to the missingness or the presence of missingness? Well, all of that is something that you need to take into account while you are building your own workflow for the imputation. Secondly, you have the data profiling. So, of course, you have to do your exploratory data analysis, but you have to go in depth. So how does your missing data looks like? Does it have correlations with different variables, especially if you are working with a data set that have multiple variables present? You have to understand whether your missingness is happening in short gaps, which are very easy to be fixed, for example, or whether your missing data is happening in long gaps where you have impacts of different behaviors, like, for example, seasonality, presence of trends, and so on and so forth. So all of this impacts the way you decide to impute your missing data. So definitely it's a step that you must not skip, and you keep it close in your iterative process of doing the data preparation. After doing the data profiling and you are happy with the information that you have, it's time to decide on what imputation should I choose. This is probably the step in your process that will take you longer. There are so many different methods to choose from when it comes to time series that, well, you probably will think, well, is this the best approach? Perhaps I should try several. Or how will the missing data impact my results? Will it bias my final conclusions or not? So afterwards, it comes to the step of when you want to evaluate the quality of your imputation, right? So you want to understand whether your imputation, it went well and introduced less bias as possible. For that, you have usually two ways to do that validation. You either check, comparing, for example, you produce fake missingness so you can have the real one to guide the results of your imputation, or you can use the classification performance. So you run your classifier on top of your data, both imputed and not imputed, and you check whether you have a good impact on the performance of the model that you have built. This is usually the flow. This is the best practices flow, but as you can imagine, there are several steps where you should make your own decisions. Specifically at the data profiling, you have to understand what questions you want to make sure to be asked from the data that you have available, and in terms of imputation, you have to decide what method to be used. This flow is usually an iterative and a cyclic flow. So as models have hyperparameter tuning, so does the data preparation. It should be also optimized towards a specific objective. And well, do you recall that I said that there are several methods for time series imputation? There are. There are too many, to be honest. So you can just go with deletion. And as you can imagine, the impact of deletion sometimes can be huge and hinder the results of the model that you are getting, especially if your data is already not that big, right? So you are losing information. Or, in other cases, you are just losing representativity and variability on your original data. That's also not that great. You have the pairwise deletion, so this is when you consider two variables together and you see how does the information from one variable can help with the other and whether it's better to just delete in the combination of both variables. So the missingness does impact both variables. Then you have, of course, deleting columns. But when it comes to imputation itself, so we decided we are not going to delete these records and we want to have them imputed. We can go with the mean, the median, the modes, and so on and so forth. We can go with interpolations, either linear, polynomial. We can select, for example, time series decomposition and seasonal adjustment. We can go for regression models, or we can go with synthetic data and generative models. All of them have pros and cons, and depending on the behavior and profile of your missing data, perhaps one fits the best, okay? But I promise you that we will have something, and you might be asking, so what if I just provide a time series data set to my ChatGPT, so this is the advanced data analytics mode, and ask ChatGPT to impute this for me. This is a generative model. It will give me some hints and recommendations on how I can build a better data set. And that's exactly what we are going to see here. So I just started by providing a data set that had medium-sized gaps of missing data, so a lot of hours. He recommended me to start by doing the profile. Well, this is not odd, right? That's definitely what I have said. So he did profiled, and afterwards he recommended me to do some imputation. And in this case, he recommended me to use the compositional method of time series to do the imputation using trends and seasonality. That's exactly what he's doing. And he tried, and he couldn't do it. Interesting, right? It was not good enough to medium gaps. So he said afterwards, why not do the linear interpolation? And I said, okay, let's try. Now he said that smoothly imputed my missing data. And I'm, okay, sounds good. But show me in more detail a specific period where I have seen missingness. And well, this is not a smooth imputation. You can see there's just a straight line being imputed where I had missing data. And that's just not good. So now you tell me that, now I'm telling you that, of course, LLMs are great. And this type of generative models have shown us several different applications, and they are great for the day-to-day. But they lack precision. And if you see here, the main recommendation from this generative model was what the majority of people would do. So what you can see here is just the general knowledge about time series imputation and the general recommendation that we have gathered with the training set that is public on how to impute missing data. And this is not good or great at all in the majority of the use cases of time series missingness. So what can we do, right? We already know that we don't want linear interpolation. We already know that perhaps different models, like, for example, the composition of time series was not good enough. And bear in mind, I have also used mice, which is the state of the art in terms of missing data imputation, and I can assure you that ChatGPT was not able even to complete the computations because it's expensive. So what I bring you is different methods. use generative AI, the same the same that is used to generate synthetic data, to do the missing data imputation for us. So synthetic data, what is it? Is data that is artificially generated, that was not collected from real-world events, and we were able to generate it because we have learned the distributions and patterns of our data through a data-driven process, which is our generative model. The generated data is also the result, or in this case, the synthetic data is also the result of the learning of the underlying multivariate data distribution, which, in this case, is conditioned to the behavior of the data that is not missing, right? Because we have that limitation. Some of our data is missing. And finally, generative models are definitely more flexible and are able to adapt to both short and long term in terms of gaps of missing data, which is something that we do not observe with models where we have to do assumptions or we have to use statistical properties that were previously observed on the data. For that, we can use, for example, models like GANs, transformers, which is something that you are probably also familiar with, variational autoencoders, Bayesian networks, GMMs, and Markov chains. All of these are generative models that will provide you the flexibility that you need to deal with different behaviors of missing data. So what is the benefits of following this approach? I've already covered one, the flexibility, but there are more. So the use of synthetic data or generative models to deal with missing data imputation can help us dealing with data anomalies. What I mean by this? So if your data set has, for example, a spike or an outlier, usually what happens with other methods is that the imputation afterwards is highly influenced by that outlier or by that spike. In case of generative models, they don't take only in consideration the last or the previous readings. They take into consideration the context. And that is what makes them so good at dealing with anomalies that are so normal and time series. And for that reason, they will produce results in terms of imputation that are less biased. We also have the flexibility and adaptability, right? So generative models don't care if you have trends, if you have seasonalities, if your data is complex, and if it's completely almost at random. They will learn it because they are data-driven. So they don't need assumptions. Like, for example, if you are from the traditional area of time series, and if you are using an ARIMA model, you need to do a lot of assumptions before selecting that model, right? They also lead to reduced bias and variance in terms of your data imputed. So high-quality synthetic data can reduce the bias and variance in the analysis results. So when you are using the synthetic data for the imputation, you are automatically reducing the bias of your model that you are producing on top of this data. And finally, and last but not least, more importantly, they do provide you speed and scale when it comes to inference. So when you are using these generative models, for example, just to impute some missingness in terms of production, they are faster to do it, and they are way more easier to manage when compared to other traditional methods. Of course, I'm not talking about millions on modes, but if we talk about mice, for example, which is based on decision trees, they will take way longer and be way heavier for just the process of missing data imputation. And, well, just to bring more clarity, I brought a specific use case just to show you. In this case, I am profiling the data with a YData profiling. We have an open source dedicated just to give you the glimpse of the quality of your data. In this case, I have used a stock data set with 4 different companies from April 2013 until April 2014. If you know this data set has no missingness. So all the missingness that I'm going to show you here was produced, humanly produced, so by me. The data set characteristic and challenge specifically is that this data set has a lot of seasonality. It has trends embedded. It's non-stationary, so it has some evolutionary mean, for example. It has also high correlation between the variables that compose this data set. And all of this does play a role when doing imputation. If you recall, ChatGPT offered several options, like mean, mice, even quadratic interpolation or polynomial interpolation. So for all the comparisons that I'm doing here, I've decided to use the recommendations that ChatGPT gave me. And that's what you are seeing here against a generative model that was produced by YData. In this case, I have just made small gaps. So this is an hourly data set, so what you see is small points, 1 hour that is missing in some areas of the series. And as you can see, all the methods behave almost the same, or all of them are doing the imputation correctly, or at least as expected. But this is not something new, right? If you only have 1 hour in an hourly data set, of course, even an interpolation will work well. So, but what about if I have several hours missing and I have continuous missingness? How will my recommended models work? And that's where things get trickier, right? So, linear interpolation, or in this case, the quadratic interpolation itself, made just a simple line. As you can see, it's the blue line, made just a very simple 2 curves, but did not follow any of the patterns expected for a time series of stock. So it missed completely any other randomness or types of spikes that is particular to this type of data set. If we go to mice, which is, for example, the standard in terms of missing data imputation, you can see like just a flat line. And the flat line is clearly for several hours, not something that will work. If you check the generative model, although it did not replicate exactly the same points that we see from the original data, if it did, that would be odd. It did replicate correctly the behavior that you would expect with some spikes. Of course, it's not perfect, but it's something that leads to way less bias when building a model on top of this data. And well, you can see another period from a different set of the same data. So for a different company, we can see that even the quadratic interpolation went crazy because the last point of our original data is an outlier. So it's a high value. And for that reason, the interpolation does a very high curve. This is just medium gaps, just several hours that are missing. And this is something very normal when working with time series. And last but not the least, I brought long gaps. So let's say we are just talking about several days in an hourly data set. How will those models behave? So probably you are already sensing the answer, right? The other models will fail. They already failed with several hours missing, let alone several days. And that's exactly, well, the other models, they didn't even compute. So all of them returned error because of the presence of too many missing values. This means that compared to what we see currently in the market that is not using generative AI, missingness is still a huge challenge for the most traditional methods of imputation. And it's something that is not enough to deal, for example, with real-world missing data challenges and the messiness of real data. In this case, I am using our generative model against the original data. And of course, it's not a perfect behavior, but it's a behavior that mimics way better what you would expect from a stock data set when compared to the original one. Remember, the other ones didn't even compute. So there is a lot of space to explore more around generative AI and how can generative AI be used even to improve the quality of data that exists. And, well, small recap. Synthetic data comes in many forms, is able to capture the complexity of many different distributions in data sets, can lead and can be used to address data quality issues such as missingness imputation that we have saw today, but it can be used also to deal with bias or lack of variability in your data sets. It can also, so generative models and synthetic data are able to cope with challenging and long periods of missingness. And finally, it is a cost-efficient way that can be used to remove access barriers. So I hope you have enjoyed this talk about the challenges of missing data imputation using generative AI and synthetic data. And well, I'll invite you to register at our community version where you can play around with this technology at ydata.ai/register. And I think that's it. Thank you so much. Oh, it seems like there is time for a couple of questions. Yes? I've shown you, for example, mice is this. Oh, of course, of course. So the question is about, of course, when we have simplistic statistical models like, for example, quadratic interpolation, they won't do the job versus a generative model that works with several millions of parameters. But how does this behave when compared to statistical models that are actually more complex? I guess that was the question, right? So, for example, and here I'm using mice, which is the state of the art in terms of statistics. Mice was not able to capture the complexity of the time series. And even for other statistical models that are more complex, like Kalman filters, they don't work in a multivariate perspective. They always work on a univariate. Even Markov chains, for example. So they always have the challenge of learning the distribution of a data set that have several different variables. And for that reason, that's one of the reasons why missing data in time series is still something, especially with long gaps, is still something very open, and even comparing to statistical models. So in this case, mice, it's the state of the art from statistics. If you go and check, you have variational autoencoders being used for that, and those are the ones that are delivering more interesting results, as we have seen today. Yes, yes, the lady, she raised before, sorry. If I can test it within balanced data sets? Yes, yes, also. If the results were good, that's the question. Yes, but it depends on how imbalanced is the data, right? So if, for example, we have a lot of imbalance for a certain population, and that population has a lot of missingness, it's very hard to impute. So there is a limit where you can use this type of models. If it has more than 60% of missingness, it won't behave.